Hello, today we'll talk about interface simulation when we call operation through the interface. So it can be demonstrated and used to simulate when we provide and require something as like API modeling. And here what we will do, we will call operation which is in this block. Here you see autopilot operation which can manipulate those values in this block, right? But also we will call that operation from this one, right? So it can input initial parameters and then manipulate those parameters with the responsibility of this operation and then pass back results. And we could use sequence diagram for that, but we'll use just interface. And first of all, we need to create some behavior, which we will have as a simple as activity diagram as here, which adds that in opaque action the property value, and then here we will choose call operation action. We don't need this target, and we'll drag this operation from this block. You see I got the inputs and I got result because this operation has those parameters, and I am connecting them, and here I'm reading results. Again, opaque action, you see like it just reads the result in whatever language, like English here, and then some delay just to get result visible. And also here what is important, we need to specify that I'm calling in specification using port. So I'm calling on this port, the port through which I'm leaving this UI block, so this one via port here. Then on another side I have this operation. So this operation pretty much if you will open it, it shall have a method, right? So we can right click on operation, go to the create method, but because this operation already has a method, so in the specification, actually, like here in the operation, right click, create the method. But because this operation already has a method, so we can just double click on the operation, and here in the operation you see the method. The method is in this case is some opaque behavior which will take the inputs. It has two parameters. You see input will add x, and that x by name it is defined here, and will generate the output. And this z is deliberately specified as intermediate value because it will be stored here. So we store the value here. Not only that we output as a result, but also store here. So now if I will go here to internal block diagram, which connects those two ports, proxy ports, I can run it. And also between in ADAS, we have also state machine, which based on Z change, you see change event, will switch from one state to another state. Now we'll execute this one. You see like I got the inputs, it passed those inputs here and switched to that one, right? And here we can see the results of this execution. So we got X and Z as the input. Oh no, actually UI A got as an input, then added the 5, right? Multiplied by 100, added the 5, and then output as a result. So let's see, was that the case? Yeah, A plus X. So X was 100, A was 5, so A came, added X, 105, and then came back. So that's a very simple case. Okay, now let's talk about more advanced case. So here in this sample we have interface definition, we have interface specific element here used. You see interface. Here we define the operations. Those operations could be grouped based on the features, like here we have request operations and response operations. They are parameterized. And then we have like consumer interface and provider interface for our system, which consists of consumer and provider. So provider has some variable. So here I will go and will create interface, but this interface in this case I'm using like a UML generic interface. Why is that? Because I want to show provide the required interface here, right? As you can see here, this block uses those operations, and this block is also realizing those operations. So those interface realization. So here we have realizing those operations and is using those operations. So here we have assigned this one here, and then I can have this smart manipulator here. You see, like provides, requires, right? And then those, and then here again we'll use this interface, and this one here, this place only provides, does not use anything, right? This provider just provides this one, and then pretty much because this one is realizing here. Now next step would be that I'm actually implementing those operations, and those operations will be implemented in my block, right? So this interface realizes them, so I can kind of get that information from consumer to provider, right? But so now next step is to realize this operation in the provider. So for that I will create interface realization and will copy with control drag this operation here to the provider. So control click and then drag it to provider, and here we have it. So now the connectivity is important, so we create internal block diagram and connect those ports. And with the regular connector, not like binding connector. Binding connector is to duplicate the values between value properties. Here we are assembling system, right? So here we have those two interfaces connected, and now here we can now input something, call this operation with the parameters, and here we would need to manipulate the operation data. So here we can use activity to call it. So we create classify behavior, create diagram, SysML activity diagram, and we'll start from the call operation action. We don't need target because this target will be automatically assigned. And here it's very important actually when we go to specification of this action to choose the port. The port is the one which will leave this action right here, so consumer. Now the operations are shown of the providers, and we'll use this operation. Okay, here we have those inputs now, and now we can generate the inputs. The most simple case is opaque action with some initial flow. And here we will generate output pin, output pin, output pin. All those output pins will provide the data to this to those parameters. And you see, I don't assign the type. The type will be automatically assigned here. You see, it was assigned as a Boolean. This one assigned as a string, and so. And now I can just take the same names, A, which is actually could be different names, B, and then C. And here I will specify that, A is equal 1, B is equal yes, and C is equal true. So that's based on the different type, and here at the end I could quit this behavior because this will call this operation, and that will be it. And now here for this one I need the method which will implement this operation. So here right click on that to create a method. And that could be the diagram, and that will be like SysML activity diagram. I have those inputs based on the parameters as activity parameter nodes. And here I can just do the simple opaque action. Is my opaque action, which would be like here, and here, and here one more. And I can input and say this will be A. Again, input, this will be B, and then input, this will be C. And now here we will print the values, print a plus x. This will add the x parameter of this block, so we can actually manipulate the values, and this will be possible to do anything pretty much as a result. Okay, now let's see how the simulation will work. So I will take this block, run the simulation, and I should get result here as a and actually I want to see all that what's happening, because I don't have any kind of confirmation what will be provided back. So let me take this and show here. So that's the results output, and maybe let's do that here. Let's drag it here, and that's input, including operation call. And let's see what's happening during simulation run. Let's slow down and see how. Okay. True is not defined. Some mistake in the syntax. Let's see what's wrong. So let's try lowercase. That should fix the problem. True. Okay, let's run again. One is coming here, yes is coming here, true is coming here. Now we have this passed here, and here we have 1, and it prints, you see, 6, and we have here yes, and we have here true, right? So 6 pretty much it's 1 plus 5, and we saw that 5 was here, right? So this is actually working as expected. There's another method to see results. You right click, run simulation, and then create sequence diagram. Create sequence diagram, run. So because this is just operation call, it has no reply, so this will be just one single operation call message. Here we have it. So thank you for watching this video, and let me know if you have any questions.